Welcome, everyone, to Ask the Expert Live. I'm Randy Stott, publisher and editor-in-chief, and today we're going to talk about EV gear manufacturing. But before I begin, I'd like to let you know that today's episode of Ask the Expert Live is sponsored by Reishauer. And Reishauer was founded in Zurich, Switzerland in 1788 as a manufacturer of hand tools, quickly developing an expertise in threaded parts and thread cutting. In 1945, they introduced the world's first continuous generating gear grinding machine. Since then, Reishauer is setting the standard for quality and productivity in gear grinding. Today, such advanced features as low noise shifting, topological grinding, and polish grinding have become synonymous with the Reishauer name. Reishauer makes it possible to manufacture efficient, quiet running, and durable transmissions. Over the years, they have developed an in-house expertise and manufacturing capability, not just for machine tools, but also for diamond dressing tools, grinding wheels, work holding, automation, and more. Reishauer has expanded this circle of competence with digital products that takes the Reishauer gear grinding process to the next level of increased NVH quality in a zero-defect production for your high-performance transmissions. For more information, I encourage you to visit Reishauer.com. And before we begin with the questions and answers, I would like to give each of our panelists the opportunity to introduce themselves. So, Oliver.
Hello. My name is Dr. Oliver Winkel. I work for Liebherr Gear Cutting Technology in Germany, and I'm the head of the Application Technology Department.
Good afternoon, everybody. My name is Pascal Diggelmann. I'm working for the Reishauer company for 10 years now, and I'm leading the application engineering team.
I'm Dr. Hermann Stadtfeld. I'm the Vice President of Bevel Gear Technology and Research and Development for Gleason Corporation. And interestingly enough, a week ago, I made my 25th anniversary with Gleason.
Congratulations.
Congratulations.
Thanks.
All right, let's begin. How has gear manufacturing changed in order to address the needs of EV gears?
Well, I think the most important is the quality. The quality demand for the part has changed a lot and has increased. This goes to gear quality, this goes to surface quality, and sometimes also chamfering requirements.
Pascal?
Well, I don't disagree, right? Quality is the number one topic. We are dealing these days with form error tolerances of around 1.5 or 2 microns, which is highly demanding. At the same time, we are dealing with surface roughness requirements. They became very important, specifically with the EV drives. So those are the topics that we are dealing with these days. I also believe that the technology itself became way more important. We are now in the procedure of bringing those technologies like twist-free grinding or surface, polish grinding to automotive mass production, which brings its challenges.
Thank you. Herman?
Yeah, to take the position of the bevel gears, because there were specifically cylindrical gear answers, or mostly, and most people think the bevel gear is completely out with EV transmission, which is actually not true, and maybe later we have a little time to elaborate on that. But one factor is that differential gears that have been forged in the past, until the 70s, they have been made with reverse cycle in a cutting process, then they have been forged. And it has shown that for electric vehicle, for the peak torques that electric vehicles have, for the NVH requirements that they have, that the forged differentials do not provide the proper strength in the root and on the surface, and also not in the NVH. And so there is a renaissance now of cut differentials, but newer methods, very modern, new, fast methods for differential gears as for electric vehicles.
Thank you. Which types of EV gears are the most difficult to manufacture, and why? Pascal?
I really don't think you can tie it to a specific workpiece, right? It's really the combination of the workpiece itself and the requirements, right? We see these days, from a cylindrical gear perspective, we are doing, most of the gears, they are pretty much the same, right? There's not that big of a variation in the transmission design, but there really is when it comes to the technology that is required to meet specific customer requirements. So it's a completely different animal if you need to topologically grind in combination with polish grinding than just conventional gear grinding. So I really believe it comes down to the technologies that need to be applied for a specific work type.
Hermann?
Yeah, I don't know if I should say something to that because it's expected that my answer is bevel gear related. However, I think that the gear quality today, the high gear quality achieved with the latest cylindrical manufacturing machines, that is excellent. And only the question or the request to improve and improve and improve, maybe that's not the only solution. I think that the experience I made with psychoacoustic optimizations, which was a project at the Aachen University, and Gleason picked it also up for applying it to bevel and high point gears, and it can also be applied to cylindrical gears. That those effects that we have certain changes from one tooth to the next, but they have to follow certain rules, and they would, for example, really be addressing the NVH problem because the strengths are already very good. So maybe it's not really looking for more and better quality. I think in one of your statements you wrote, they still have to be produced in mass production. Mm-hmm. And I think the quality today is so excellent in the latest cylindrical gear manufacturing that maybe we have to look in that direction also in parallel.
Oliver, would you like to add anything?
Yeah. To me, in general, most of the gears are the same like they have before. They're just in a much higher quality. To me, one of the parts that is more or less new is the step pinion that you find in planetary electric vehicle gearboxes. It's a step pinion, two gears very close to each other, a very tight and precise timing. I think that is pretty challenging.
If I may, I just want to add on I completely agree with your statement, right? I think there is this false belief that a tight enough tolerance is going to fix everything.
Exactly.
And I don't think that's right,
And we all remember that when gears started to be ground, everybody was wondering why they weren't quiet. In the bevel world, it was like compared to the lap bevel gears. And they automatically had what the psychoacoustic changes do. They had that from tooth to tooth. And we all were saying, why are they loud? They're ground. And then somebody else answered, yeah, that's the reason why they're loud. They're so precise that the impact, the first harmonic impact, that comes exactly one after pitch after next, and that kind of builds up then, and all the harmonics are pretty high. So really, that's not the only solution to make a gear quiet, because they are so accurate already. However, the threaded wheel grinding, the honing, the combination of making a pinion different with a different process than the gear, I think those effects, they would rather help just than increasing the gear quality.
So what specific requirements for EV gears are the most challenging? If it's not the quality, what is it? Go ahead.
From our point of view, it's probably, controlling in a mass production environment surface roughness. Whether you do that with fine grinding or with polish grinding, to me, that's number one topic that we're dealing with. Next to all the other things that were mentioned already, right? The form errors. But to me, controlling surface roughness, that's probably the number one topic right now.
Yeah, I would agree. One thing is to create a very good surface roughness, like polishing. The next one is where to check it: top, bottom, tip, root, and I think we are approaching the technical limits of what can be measured. So how accurate and repeatable is the measuring device that we use to qualify a polished surface? And then some people are dreaming of process capability on on surface. I think that is not today maybe not possible on this high level that we are. So we are approaching many things, not only what can be done, but also how to be checked and how to integrate in our process capability ideas and this kind of stuff.
Yeah, and this is where we as machine tool manufacturers need to be honest with our customers also, right? We need to be transparent about what's achievable and what is not, right? I think that needs an open, which is not always easy, I know that, right? But it needs an open, honest conversation about those topics with the customer.
I think regarding the measurement, you're having a question later that you wanted to ask about measurement. I don't know how deep we should go, but I agree with Oliver that a regular measurement, like with a ruby, scanning or point measurement, tracing the lead, the profile, or making an entire grid will not do the trick. It will be a combination. I even think that optical measurement, like laser surface measurement, and contrasters that are on the measurement, on the CMM, and then the direction, you do the profile and the lead, and they say the one is the waviness and the other is the roughness. It ain't, because you really should go where the contact lines go. And if you have a helical, they are not horizontal, they are under an angle. And when you go perpendicular, those kind of things probably have to be more than they were in the past, because they were often ignored in the past.
So what are the technologies that are going to help manufacturers solve these problems?
I believe the technologies, they are there already, right? We know polish grinding, we know fine grinding. What we see from our point of view, we are very much in the process of refining those technologies with all the, statistical evaluation of surface roughness. We came to learn a great many things, right? Because it's a difference whether you look at an isolated gear or if you actually look at 100 or 200 gears, over the whole face width of a grinding wheel, over the whole range of diameter of the grinding wheel. It makes things visible that we just, come to understand, and we learn out of that. And as I said, we are refining those processes right now, actually.
Anybody else?
I see also the effect that measuring, production, innovation, this is a back and forth. Yeah? If we can produce surfaces for function elements like gears, which have never been measured so accurate before, there will also be the demand brought to the measuring. You talked about the laser measurement. Before that was not necessary. You measure profile lead, everybody was happy.
Okay.
Yeah? And then we talked about twist free, and everybody was measuring more lines. And now we are talking about ripples and waviness, so maybe we have to have the full topography. So the same is not only topography, but also surface quality. Maybe there will be in 2, 5, 10 years new and more reliable measurement systems to really evaluate these surfaces, different than we do today.
But regarding the machine tools, our answer should be, among the three of us, we have all the technology it's needed for the finest electric vehicle transmissions.
Very good.
Oliver, you didn't look very convincing. You agree?
Yes, hopefully.
Of course, we have to work hard on it, and it was meant to be a funny statement.
This is why I'm smiling. Every time I believe, now I have the solution, someone comes up with an even bigger
More
challenge.
requirement.
Yeah.
But what about that? I mentioned that to you before. The Europeans, they have, I know it's in Germany, probably the European Union, they have this law now that an electric vehicle has to make a sound, some mechanical sound. And I don't know if that sound is allowed, you might know, if that sound is allowed to turn off after 50 miles or when you drive 100 miles per hour, if it can turn off, because then you still would hear the gear noise. But if that sound is constantly there, that would really mask the noise and would help us and the driver of the vehicle.
I heard of it. As far as I know, the reason is that the cars are so silent that you don't hear them anymore.
Pedestrian children,
and many people are trained like us you hear that the car is coming. And if you don't hear it anymore, you might pass the street and get run over. And after 20, 30 kilometers an hour, the tire and the air noise is so high that you start to hear it again. So that is the idea. In one point that's strange, you want to have an absolutely silent car, and if it's really absolutely silent, it's a problem.
So we talked a little bit about this, and I think Hermann maybe had another thing or two to say, but how have inspection requirements changed for EV gears?
Yeah, I mean, the three of us already mentioned that, right? It's not only the manufacturing technology, it is how you inspect it. And I think it's a combination. You would do for your basic flank form and for your machine settings, you would do a surface grid or lead and profile measurements. And then you would have to see maybe surface roughness. And surface roughness itself and surface waviness as it is defined by the contracers, that can also not really be done by laser measurement. So you would really need that sharp needle point that falls into the valleys and so on. And modern CMM machines have changers, probe changers, and they can put that contrasting roughness measurement probe on. But then again, there are certain textures and surface effects like structure that both the Ruby as well as the contracer cannot do, and that's where the laser measurement comes in. And I think, probably because those are the three technologies that are there today, that it could be a combination of those three, that you have for each, because I see so far laser measurement most in a laboratory environment. It is very seldom used in production. But now with the electric vehicle requirements, it probably finds its way into the production as well.
Yeah, we see, right, and this is more, we see that everywhere. We are increasing the magnification. We do that literally on the gear chart, right, where we measure 1,000:1, just as a new standard for all the EV drive applications. But at the same time, gravel analysis became way more important, right? We are now dealing with tolerances that are specified on the gear chart for certain orders, not to exceed a, given amplitude. And we even have customers that bring it to a whole new level, while they are not only specifying the amplitude, but also the direction of that waviness, which requires you then to do basically measure the full topography of a gear flank. What I also would like to mention is the ability of in-process monitoring, having a system that allows you to monitor your process real time, not only the process itself, but also the components, which then, really allows you to reliably manufacture gears in a mass production environment.
I mean, that's an important point, because we said now, we started with what can we do on the gear with the processes, and then we said we have to inspect them. But now we have the inspection in front of us, and we look at them and say, what to do with that now? It tells us something, but we don't know exactly. So how can we flow that back into the process? How can we monitor the process that things that we see there can be correlated? That is probably an interesting, challenge for the future.
Absolutely. I think that's going to keep us busy for the next years to
Yeah,
come, right?
We don't have to worry not to be
Exactly.
busy, you're right.
Yes.
I also agree to that point because I think we have now more the chance than in the past to see what we are looking at. You talked about maybe in former times the idea was if you want to have a quiet gear, just produce it in a better quality. That does not always lead in the right direction.
Exactly.
Yeah? Today with the, as you mentioned, waviness and ripple analysis, we have a much better idea what is our problem. Because I think there is no gear in the world that has absolutely no waviness, but not every waviness is a problem. And
Yeah.
I know times when really noise analysis was full try and error, and 3 or 4 people were looking and listening to it and try to find out. And now we are looking on this analysis and we know which orders we have to find, and I think we all have solutions what we can do against that. So you see your enemy, you can really fight against it, and not just by try and error or just reduce it by 1 DIN or ISO class. That's a big step forward.
So what are the solutions to solving gear whine? What are the things that you can do on the manufacturing side to improve the NVH performance?
Well, from my point of view, you can work with the technology. You can work on dressing. You can work on the way you are grinding, the additional movements that you make. You can more clearly look on deviations. Because in some cases, if you see the order, you know where it comes from. Yeah? You have always some deflections. It can be the run out of the fixture, the run out of the dresser, some unbalancing, maybe also the table bearing is not 100% anymore. So you see on the frequencies what you have to do. And I think these are some of the points that you can do mechanically, electronically to improve it. You see it?
I fully agree. I think what needs to happen, in order to deal with these NVH issues, we really have to find a deep and good understanding on, what are those correlations, as you mentioned, right? How is an imbalance in the grinding wheel affecting, certain imperfection on a gear? How can we control what process parameters are controlling the direction of a certain waviness, right? That, makes it more or less critical for a resulting gear noise. And I think that must be the first step, that we really understand how are those relationships, how are those correlations in order to control them.
Regarding the gear whine, I have something that came up with bevel gears, with the straight bevel differential gears. Interestingly enough, there are so many solutions out there, or different solutions. It appears that what we see is only the standard solution, a 2-stage or 3-stage cylindrical transmission, and then there is, in most 90% of the cases, there is a differential in there. But there are other solutions that are not so standard. For example, there's one American manufacturer of electric vehicles. They even have a patented transmission, and their differential is actually located 1 stage before the end stage. So it runs then faster and would about, when you drive around the bend, about run 6 times faster, so the relative speed. And those gears, they can actually whine. So they have, the relative speed is pretty low. So you would imagine that what is the whining? It's a higher order frequency. And where does it come from? However, it has been found that when you exchange that forged differential by a cut differential with a completely different surface texture, maybe more accuracy, but a texture there where the forged one has this grinding scale. That seems to be almost a mirror image, but it's not really a good surface as with a high integrity as you want a gear surface. And so the whine was gone, and maybe we can learn something out of that. Analyze why is the whine there with that surface of the forged gear set, and why was the whine gone when we used a cut gear.
Thank you.
Not only answers, but also questions, right, in the answers. Yeah.
And I'd like to also point out that if anybody in the audience has questions, please just raise your hand. We'll get it asked. Thank you. How has EV gear design changed over the years, and what changes can we expect next? What challenges are you facing, and do you think you will be facing in the next few years?
I can start for the bevel side. It might make it easier to answer because there are more things to say in the cylindrical probably. But like I said before, some people in the audience also, they think that the bevel is out. There is this standard solution. Everything is put between the wheels, and why would it need a bevel gear set? But there are some very interesting solutions out there. There are 2 American manufacturers that say for heavier vehicles, it would be good to also have, not the E-beam where everything is between the wheels, and the unsprung weight gets about twice as high, and the truck drives on a highway with the pavement not exactly even, and the axle tramples. That costs efficiency, that costs tires, and it's also not a safe driving conditions if it's, for example, rainy or so. So that unsprung weight in an axle, I think this is what every automotive engineer doesn't want. So now this solution is, those manufacturers, they made their homework. They said, most people out there that making electric vehicle transmissions, what they don't know is that a hypoid doesn't have 70% or 85% efficiency. It has 96 to 98% efficiency if it's done right. Modern high-point like it's in most vehicles. If I combine that with 2 stages of cylindrical gears, I can get up to a ratio of 45. You know, most of those 2 or 3 stage cylindrical gear sets, they have a ratio of 9. But everybody says the electric motor should run 20,000, maybe more RPM. How would it do that? If it's a ratio of 9, it only needs to run 10,000 or 8,000. That's not a modern concept. That's something in between. I'm doing something to be able to sell an electric vehicle because maybe the direction to go comes later. So those manufacturers say that would be an ideal solution, and they made their homework regarding the efficiency and calculated that 2 cylindrical stages combined with 1 high-point stage as an overall packaging with a ratio of 45 have a better ratio as if you do everything with cylindrical gear stages. Another manufacturer that found that in-wheel, you know, the wheel hub drive, not a very optimal solution because of the low RPM, you know, until you get 30 miles per hour, it's not even rotating, but the electric field is rotating like hell and you need to power a lot of amps in and the wheel heats up and everything. So that manufacturer said, we put in a large cylindrical bevel gear set, spiral bevel gear set, with a pinion inside of the rim and then electric motor crosswise, and now we have a ratio of 8 or something like that. And the motor can run 8 times faster than the pancake style motor. So that's another bevel solution that is completely different. And we have also actually one manufacturer or 2 manufacturers. One is actually already almost done that did the double differential, that high reduction, where we have 8 spiral bevel gears in a very small packaging where we can realize ratios up to 100. So I'm not sure which of the one will make it, or if there will be there definitely will be some kind of a variety. It will not stay exactly where it is now, where you need to put the motor, the transmission, the differential, everything between the wheels. That can't be the final solution. There must be something that is more refined and maybe more optimal in an entire vehicle concept.
Yes.
If I start for the cylindrical gears, from my point of view, if I take out the step pinion that I talked before, if I just put 5 drawings on the floor, they look like normal gears that you had also in manual or automatic transmissions. So in general, from the design, they are not so much different. What is different is the properties that they have to have, not the macro but the micro geometry. I mean, you talked about we have an RPM of maybe 20,000, making it easy. My diesel engine runs at roughly average 2,000. So we have 10 times the load cycles for the same usage. That means that the gear has to have the same, maybe not the same torque, but a much higher number of load cycles. And so we have to transfer, and this is done, knowledge from aerospace, from turbo gearboxes into automotive transmissions. It is knowledge that was there, but it's not used this way. If you look at an electric gearbox, it does look like a normal industrial gearbox. You have 2 stages of cylindrical gears and 1 motor. I mean, we have here in the shop floor dozens of companies making these gearboxes, but not in that volume and not in that quality. And normally the NVH requirement is slightly lower. Right. But it's not really new, but the bringing different demands together, that makes it so special. And it is why we are talking about microgeometry and surface finish and shot peening and all this kind of stuff.
Yeah, there's not much to add, right? Most of it has been said. Maybe what we also see, we see a tendency of the work pieces that we get on my, table for evaluation. They do show a tendency getting larger, right? For the, pickup truck applications, so that requires, from our end, we have the dual spindle up to 260 millimeters. That does require, in our case, in some cases, to go to the larger machine tools. But other than that, most of it had been said to this question.
Okay, thank you.
Maybe if I add a small point, also side features are getting more important. In the old times, gears were cut and then we used press chamfering. Now, the requirements, even to something so unimportant like a chamfer, has increased, not only on externals, but also on internals. Before it was just, okay, get rid of this burr. And now the chamfer is part of a design feature. So also these side operations become more and more important, fascinatingly.
Are there any other components of the design that are becoming more important and needs special or advanced technology, things that will help them solve the noise and whine issues?
It's going to be a combination of different things, I believe. In the very end, there is no easy answer to this. But maybe just I'd like to add, when we are talking about all these new requirements and how increasingly tough it is to achieve those, we as a company have only been successful where we have been working closely with the customer together. I think this really is, what we are facing these days is a learning curve for everybody that is involved, involving us, the machine tool manufacturers, but also our customers. And I think we only can be successful when we are really, closely working together and learn together on improving, the result.
And there is not, we could say there is not that much to it except good gears. I mean, the bearings, seal rings, the transmission housing, there could be something done with the ribs or so, with dampening in order to get the noise down. But it's all conventional, right? It's similar problems that we had in the past. It's really only, we could say maybe we didn't look enough at the bearings. Maybe the bearings should be different, they have to be different. They're rotating a little bit faster, the forces are slightly different, and bearings can contribute a lot to noise. You can make super good gears, but the bearings really amplify and transmit it to the housing. But that's all kind of conventional, and I think that the bearing manufacturers, they are asked the same questions that we are asked.
Hopefully.
Yeah, hopefully, yeah.
There's a question.
Yeah? Yeah.
Twist control, yes?
All the gears in the EV gearbox require twist control?
No, they don't. No.
What kind of EV gearboxes doesn't require?
Most of them, actually. We see, to be honest, from our point of view, there are some that still do twist control or twist-free applications for EV drives, but most of them do not, actually. We even see a tendency of, because it's not, it's a more expensive process, right? We see a tendency more going towards polishing and less going towards topological grinding, actually. Yeah. I'm not sure if that's different in your experience.
I like this answer very much because I think it's a good point to say, from the times in the Sigma pool when we had the chance to look a little bit in the bevel gear technology, I always admired that they are thinking in ease off. They are not thinking in one gear and another gear, but two together. And in general, twist-free is just the property of one gear. And in general, what is important, how they behave together. So the question is, how does the other gear look like? Yeah? So even if both gears are twist-free, this does not mean that this is the optimum. You have to look for the perfect topography. That could be, in the specific case, it could be twist-free, it could be modified, it could be overcompensated, whatsoever. You have to find the best topography and then find a principle to manufacture that. And I think a lot of people had done a lot of work to be able to do that. I would say today, as you said, are all these gears twist-free? No. Are many of those modified? Yes.
We mentioned a couple times the polishing. We might be of different opinion, or we might have an opinion that is formed by our customer. But I have two statements to the polishing. If you take, in the bevel world, that's true. That's definitely true. And in the cylindrical world, it might be partially true. If you take a high-point gear set or a spiral bevel gear set, and you have it out of production, let's say ground, has a good surface form, but there is a certain roughness on the surface, even though RA might be better than 0.5 microns, but there is a certain roughness there. We put it in the gearbox, and we drive it now 1,000 miles, maybe 2,000 miles. We take it out of the gearbox, it looks like polished. Why would we want to invest the money in polishing if the gear set polishes itself? The second statement is, by polishing a gear set, when it's just coming out of the grinding machine, we take away the ability of the pair to break in with each other, because the polishing is an artificial break-in, but it doesn't mean the pinion breaks in with the gear to a proper pair, but the pinion is already done independently, the gear is done independently. We just put them together. And my third, I only wanted to have two statements, now I have a third one. You know, during the break-in process, when the gear set is fresh, it really makes, it undergoes a procedure that helps the gear set to become better in a pair and then survive for a long time. Because when we have wrong surfaces, something wrong with the surface, a pickup like a scoring on the surface due to wrong oil or due to something happens in the first 1,000 miles. It doesn't happen after 50,000 miles anymore. And that also means that maybe the initial texture that the surface has is good for oil adhesion, for oil pockets, and to help also this break-in process. So I'm not really, I think it's governmental requirements that the vehicle, when it comes out of the factory, it needs a certain overall efficiency. And with the polishing, you get that efficiency, but it would be equal or better if you let the gear set break in for 1,000 miles or 2,000.
That's interesting that you mentioned it. I was just having that conversation like an hour ago.
Yeah.
And I was told the same thing, right? You know, basically, you know, when you, after a couple of 1,000 miles, you know, the gear set polishes itself, right? But, you know, the unfortunate part, right, at the same time is, you know, in the very end, it's not us that is defining the requirements. But from a technical point of view, I fully agree, yeah.
But you agree that all those government people and all those people that make in the DOT and everywhere else that make the rules and the laws, they should have people like us also to advise them, at least to listen to us what we have to say and what you have to say. But they don't listen to the gear people. They listen to something that is really artificial and way from reality.
I encourage myself to disagree regarding the polishing.
I hoped one of the two of you would.
I agree that if you're running a gear set, after some time it looks polished. On the other hand, it is proven by many research activities that if you have this polished surface from the beginning, it lasts longer. So you really have an increase in the lifetime, which especially on the EV gears is a problem. I talked about this high load circles. So that is a proven point. You don't have this initial wear, you're starting on a smoother surface, and so they last longer. The other point is, I agree that trying to create a roughness of zero might not be the goal. What we do sometimes is we make some kind of surface engineering. So our customers, we are not thinking about RZ and RA values anymore. We're talking about RPK, RVK, material ratio. These are the new characteristics. And some people want to have a specific RPK and a specific RVK, so meaning smooth tops and some grooves for oil or whatsoever. So they want to have it as smooth as possible, but some kind of special surface. And this also is something that was brought up. It's not the goal to be perfect. You want to have a specific surface.
I mean, I believe that in the cylindrical technology, that what you just described, that specific surface, what I was more saying is like you throw them in a ram tank and you just kind of let them with the stones polish, right? Mm-hmm. And that's kind of not really helping the gear set. So I believe that new technologies, as they have been developed in connection with cylindrical gears for polishing, that they do more than that. And those technologies do not exist for bevel gears. Therefore, you know, you would throw them in a ram tank, get them out of there looking beautiful, but you know, it's not always the looks. If it's a mirror finish, that really is an optimal gear set. So in the bevel world, I would, at this time, not see a viable process, you know, to do a polishing that's similar like what we do in cylindrical gears.
Maybe not yet, you can invent it.
You're right. Tonight when we meet.
Very good, thank you. Can you tell me a little bit about how the introduction of new vehicle manufacturers, new players in the field, has impacted the requirements of what you have to do?
If I may answer that, you know, it's different. It absolutely is. It requires more of a open and active communication, right? Because this is really where we need to talk to, you know, some of those specific customers, right? What it means to put a given technologies, you know, that is attached to certain requirements into mass production, you know. And we have to have this conversation, you know, transparently and openly, honestly, right, with those people in order, we shouldn't overpromise, right? We should make clear what's achievable and what is not. And that's probably one of the main points that is different with these new players, you know. Because many of those requirements, you know, they are a result of, you know, simulation, you know, let's say, but they're not always based on real world experience, if you, yeah.
I mean, I already mentioned, when I again speak for the bevel now, that, for example, that wheel hub drive or a spiral bevel gear, those gears, they be from the design like aircraft gears. You know, they hollowed out in the back because you really want that unsprung weight to keep low in the wheel. And then the other designs that I like, the differential, for example, who would have known that actually not we went to our customers or users and said, cut differentials are better than the ones that you use. No, they came and said, we have a suspicion. Would we make a trial program? Because the old reverse cycle method that we use really produces better gears than from the forging. And if you have something more modern to offer, so that is another notion, you know, that was before electric vehicle, nobody would have thought of that such a renaissance in the differential would even be possible. And then other solutions like the combination on a beam axle on a heavy Class 8 truck to have a high put set with two cylindrical and then the electric motor and that be with a drive shaft uncoupled so that the unsprung weight of the beam is not that high. Those kind of things I see in the bevel world. So I don't see the bevel is out, but I also see that, you know, in order to get that on the road, this is now all, you know, in design, we're making samples, we kind of testing something out, but to get that all, not the differential, that can be because it's so compatible, it goes right where the forged differential was, but the other solutions, that will take half a decade to get that on the road.
Yes? All right. What advice would you give to gear manufacturers who are interested in getting more involved in the EV space?
Well, I think many points have been mentioned, right? You know, it's increasingly challenging, you know, to produce the required quality. So, you know, if you want to get into that space, you know, get ready to, you know, have a steep learning curve, I believe, right? Get the right machine tools. And yeah, pick up fast, I believe, right? These times are extremely challenging for all of us, I believe, right? I think there's no exception to this. At the same time, it's actually exciting, right? Because we are now in the process of learning so much. We are learning so much about our technology, about our processes, but also about our machine tools. Things that just come by the fact that we increase the magnification so much, right? So we look at data, you know, and we see certain correlations that have always been there. You know, it's not new, but by increasing the magnification, they become visible.
Yeah.
And that's exciting, actually, you know.
You know, I would give them the advice, be also more proactive as you were in the past. When somebody came to you and said, I want a transmission for a lifting device or a conveyor belt or something, you made the transmission exactly, they said the width, the length, and so on, and the ratio, and that was basically, and the power rating, and that was basically it. I think because the automotive industry doesn't really know exactly the direction, the transmission designers, those are designers of automatic and shift transmissions. They never designed those transmissions that look like industrial gearboxes. They didn't do that before. So they are also need some advice, some guidance, because they don't have that experience. So I think that a transmission manufacturer that likes to get in the EV space, it's also asked not just to sit there, try to make the highest gear quality possible and follow exactly like a slave the input that you got from your customer. Work with them together and be proactive with solutions and ideas.
Yeah, I like to express a wish, which is a hint. Everybody who's going into electric vehicles, my wish would be look more on the quality of the blanks. Very often we are expected to improve a part if we grind it. Of course we do, but very often the blank is the limit or the critical factor. We're talking about runout, especially phase runout of the blanks has a very high impact on gear quality. And we see that very often that we have tolerances 0.05, 0.03 millimeters phase runout. This is too much for the typical EV gears to perform in the end. You can grind them as good as you want, they won't perform. So look carefully on the blank quality. And the other one is, we talked about a lot, how can we grind gears better? How can we manufacture them better? I think also the design is important. If you have a poor design, it will be noisy. You can grind them as good as you want. If you make an incredible high tip relief, or you have a huge crowning or the wrong topography, you can grind them in quality 0 and they will be noisy. So please look in both directions, not only improving quality, but also improving the design. Would be my wish. Maybe it happens.
Regarding the blanks, I also think the heat treatment of the blanks. The heat treatment in soft before a cutting operation is done, and then also after case carburizing, etc., how it's normalized and so on, and how it's tempered. I think that the blank quality, not only physically the dimensions, but also the structure should be optimal or optimized more than it is today.
Very good, thank you. Do we have any other questions from the audience?
Dr. Ligata.
All right, then I would like to thank all of our panelists for joining us today and sharing their knowledge and expertise. And once again, I'd like to give special thanks to Reishauer for sponsoring the event. But before you go, if you're interested in the future of electric vehicles, I strongly urge you to attend AGMA's EV Town Hall meeting on Thursday at 8 a.m., where you'll have the opportunity to help the association determine the future work in the EV space. Thanks, everyone.